Jensen Huang just gave a 2-hour keynote at GTC 2026 in front of 30,000 people. And every headline you're going to see tomorrow says the same thing. $1 trillion. That's the number. Nvidia says purchase orders for Blackwell and Vera Rubin will hit $1 trillion through 2027. And so everyone's going to cover that number. They're going to cover the new chips, the new partnerships, the robots, and the Disney character that showed up on stage. What nobody is going to cover is what actually happened underneath all of that. Because if you pay attention to the announcements, not the headlines, the actual announcements, Nvidia just told you exactly how the next 3 years of AI play out. And some of it is legitimately groundbreaking. I build AI products for a living. I've been covering AI agents and AI infrastructure for this channel every single day. And I'm going to walk you through every major announcement, what it actually means, and the 3 things Nvidia announced today that change everything for builders and developers. And so let's start with the hardware, because the hardware story at this GTC is actually 2 stories. Story 1, Vera Rubin. This is Nvidia's next generation AI data center platform. Jensen had the whole thing on stage, a full rack system with 1.3 million components. Custom CPU they designed from scratch specifically so AI agents can think faster. And the number that matters, it processes 350 times more AI tokens per second than the system it replaces, right? Not 10% better, not twice as good, 350 times. At 10 times the performance per watt, which means it does dramatically more work while using dramatically less energy. The first system is already running in Microsoft Azure. And so that's impressive on its own. But here's where it gets interesting. Story 2, Groq 3. Nvidia spent $20 billion in December to acquire a company called Groq. Not Groq with Elon Musk, Groq with a Q. Founded by the people who built Google's tensor processing unit. And today, Jensen unveiled the Groq 3 language processing unit. It ships Q3 this year. And why does this matter? Because it's an admission. And so GPUs are built for throughput, right? You throw massive parallel workloads at them and they chew through it. But throughput and latency are enemies of each other. Jensen said that on stage. Those are his words. Enemies. Think about it this way. A GPU is like a cargo ship. It moves enormous amounts of stuff, but it's slow to turn around. An AI agent that needs to respond to you instantly needs something more like a speedboat. Fast reactions, low delay, and so instead of trying to make the cargo ship faster, Nvidia spent $20 billion to buy a company that already built this speedboat. The Groq LPU is a completely different chip architecture optimized for instant response. And when you put it next to the GPU in the same rack, Jensen's claim, 35 times better tokens per watt. Said differently, the same electricity that runs AI today could run 35 times more AI tomorrow. And so what does that actually mean for you? It means the cost of running AI drops dramatically, right? If you're a developer building on cloud APIs, the inference costs you pay are directly tied to how efficient these data centers are. A 35x improvements in tokens per watt means the tokens you buy in 2027 will cost a fraction of what they cost today. That's not speculation, that's math. The hardware dictates the economics. And then Jensen showed the roadmap. Vera Rubin ships second half of this year. A second version called Vera Rubin Ultra in 2027 that connects even more chips together for larger workloads. And then Feynman in 2028. An entirely new architecture. 3 generations of chips mapped out in advance. No other chip company gives you that kind of visibility. And that's strategic because switching costs increase with every generation. Once you build your stack on Nvidia's architecture, leaving gets harder every year. If this is valuable to you, I'm posting a new video every single day breaking down what's actually happening in AI, just data, sources, and frameworks you can actually use. And if you're building software with AI, I built UiPunch, an AI UI code generator, so your layouts come from what actual ship products look like, not hallucinated generated templates. Link in the description, hit subscribe. And so the hardware is one half of the story. The other half is software. And this is where the keynote got really fascinating. Jensen Huang spent a significant portion of his keynote talking about OpenClaw. If you watch my video the other day on AI agents, you know the landscape. OpenClaw is the fastest growing open source project in history. 247,000 GitHub stars. And it has massive security problems. 824 malicious plugins, critical vulnerabilities, 30,000 exposed instances on the public internet. I covered all of this the other day in detail. And so what did Nvidia do? They built NemoClaw, an open source enterprise secure reference stack specifically designed to make OpenClaw safe for businesses. And Jensen didn't just mention it, he devoted a huge chunk of the keynote to it. He compared OpenClaw to Windows, his exact framing. OpenClaw has open sourced the operating system of agentic computers. And then he said every company in the world needs an OpenClaw strategy. Now think about what that means, right? Nvidia is not an agent company. They're a hardware company. They sell chips, and they told every enterprise in the world that they need an agent strategy and that Nvidia built the security layer for it. And here's the part that matters for builders. NemoClaw includes something called OpenShell, a runtime policy engine for AI agents. Nvidia pitched it as the policy engine for all the SaaS companies in the world. That's the actual quote. Microsoft Security is already partnering on it for adversarial protection. And the whole thing is open source and runs locally on DGX Spark. And so the business model becomes clear, right? Nvidia doesn't charge you for NemoClaw. It's free. But to run it locally at enterprise scale, you need DGX hardware, which Nvidia sells. The software is the bait. The hardware is the hook. Same strategy as CUDA 20 years ago. Give away the programming framework, sell the chips that run it. And it works so well with CUDA that Nvidia became a $4.6 trillion company. Now they're running the same play with agents. But here's the thing, and this is what I mean about paying attention to what Nvidia is actually telling you. NemoClaw's entire existence validates every criticism of OpenClaw's security, right? Nvidia didn't build an enterprise security layer for a tool that was already safe. They built it because it wasn't. CrowdStrike released a removal tool for OpenClaw in February. Kaspersky found 512 vulnerabilities. And now Nvidia is saying, we'll fix it, just run it on our hardware. That's the move, and it's a very smart one. And so something unexpected happened at what is usually a pure enterprise keynote. Jensen announced DLSS 5, and this one genuinely surprised me. Previous versions of DLSS were about performance. Make games run faster by having AI fill in pixels so the GPU doesn't have to render every single one. DLSS 5 is different. It's about visual quality. It uses AI to look at every frame of a game and add photoreal lighting, materials, skin detail, fabric texture, not making the game run faster, making the game look real. Jensen called it the GPT moment for graphics. And so what does it actually look like? They showed it running Resident Evil Requiem, Starfield Hogwarts Legacy, Assassin's Creed Shadows. Todd Howard from Bethesda was quoted saying when they got it running in Starfield, it was amazing how it brought it to life. Capcom, Ubisoft, Warner Brothers, and a bunch of other publishers are already committed, and it launches this fall. But, and this is important, the demo required two RTX 5090s, one GPU to run the game, and a second GPU dedicated entirely to the DLSS 5 neural neural rendering. That is a lot of compute. Nvidia says it's designed to ship on a single GPU, and the demo was just a snapshot of current development. And that might be true, but fall 2026 is 6 months away, and right now it takes two of their best GPUs to run it, right? So watch that one carefully, because the promise is extraordinary, but the engineering might not be done. And so now let's talk about the partnerships, because this is where GTC keynotes always get interesting if you know how to read them. Partnership 1, Thinking Machines Lab, founded by Mira, former CTO of OpenAI. She was the one who served as interim CEO in 2023, and she left OpenAI last year and started this company. And Nvidia just signed a multi-year deal for at least 1 gigawatt of Vera Rubin systems. To put that in perspective, 1 gigawatt is enough electricity to power a mid-sized city. Jensen estimated last year that building 1 gigawatt of AI data center capacity cost between $50 and $60 billion. That's one deal, one startup, one signature. And so this is a massive deal. And so let me show you the pattern, because I think people miss this. Nvidia invests in a startup. The startup uses that investment to buy Nvidia chips. The chips show up as Nvidia revenue, and then Nvidia points to the revenue as proof of demand, right? It's circular. They've done this across their portfolio. Nvidia participated in Thinking Machines' $2 billion seed round. Now, Thinking Machines is committing to tens of billions in Nvidia hardware. That's the same capital flowing in a circle. Now, does that mean the demand isn't real? No. The demand for AI compute is genuinely enormous, but it means that when you hear $1 trillion in purchase orders, you should ask how much of that is organic demand from customers spending their own money versus how much is Nvidia recycling capital through its own investment portfolio. Those are different things, and the headlines don't distinguish between them. Partnership 2, AWS. Over 1 million Nvidia GPUs deploying this year across Amazon's global cloud. This one's straightforward. AWS needs chips. Nvidia has chips, real demand, no circular financing. Just a massive customer writing a massive check. Partnership 3, Uber. This one's fascinating. Nvidia and Uber are building a fleet powered by Nvidia's Drive AV software. 28 cities across 4 continents by 2028, starting in LA and San Francisco next year. The target is 100,000 autonomous vehicles. Jensen said this on stage. The ChatGPT moment for self-driving cars has arrived. Hyundai, Nissan, and Geely are all building fully autonomous vehicles. Level 4, meaning no human driver required, on Nvidia's platform. And Nvidia launched something called the Halos Certified Program, the first industry system to evaluate and certify safety for autonomous AI. And so the self-driving piece is worth paying attention to, because it represents Nvidia moving beyond just selling hardware to owning the software stack that the cars run on. That's recurring revenue. That's a completely different business model than selling chips to data centers. And so the last major piece is what Nvidia is doing with models, because this quietly might be the most important announcement for developers. Nvidia created the NemoClaw coalition, 6 families of open source AI models covering every major domain: language and reasoning, vision and world simulation, robotics, self-driving cars, drug discovery, weather and climate, and they brought in partners: Perplexity, Mistral, Cursor, LangChain, Black Forest Labs, Thinking Machines, and others to build on top of these open models. And so think about what this does, right? Nvidia is saying, we don't just sell the hardware that runs AI. We also provide the open source models that AI runs on, and the enterprise security layer that makes agents deployable, and the developer tools that make building easier. Hardware, models, security, tools, that's the entire stack, top to bottom. Jensen said on stage, we are now a computing platform that runs all of AI. And so let me give you the takeaway. 3 things that genuinely matter from GTC 2026. 1, the Groq acquisition changes the economics of AI. Every API call, every chatbot response, every AI agent action gets dramatically cheaper. That that flows directly to every developer and every person using AI products. 2. NemoClaw turns AI agents from a security nightmare into an enterprise product, and it locks the enterprise into Nvidia's hardware. Same playbook as CUDA. Bet against it at your own risk. 3. DLSS 5 is the beginning of AI replacing traditional computer graphics in real time. The tech isn't ready today, but the direction is clear. Video games are about to look like movies. The skepticism. The trillion-dollar number includes circular financing. The 3-generation roadmap builds dependency by design, and the gaming demo that required $2,000 GPUs to run should be noted, not ignored. That's what actually happened at GTC 2026. Thank you, and I'll see you tomorrow.